Now let's see exactly one type of chemical bond, that is ionic bond, or we also call it as electrovalent bond. So what is this ionic bond or electrovalent bond? Already you had learnt in 9th and 10th standard, easy topic. An ionic bond is formed by transfer of electrons, isn't it? So how the electrons are transferred? From where to where? From an electropositive atom to an electronegative atom. So what is an electropositive atom? An atom which is having more tendency to lose electron, that is called as electropositive atom. Then what is this electronegative atom? The one which is having more tendency to accept electron, that is the electronegative atom. So electrons are always lost from an electropositive atom and gained by the electronegative atom. So this transfer of electrons takes place during the formation of ionic bond. Then what is happening along with that? So atom losing electrons become a positive ion, that is cation, while the other atom gaining the electrons, that become the anion, that is the negative ion. So after the electron transfer, the atom which is losing the electron, that is becoming a positive ion, and the other one which is accepting the electron, that is becoming a negative ion. So whenever we have oppositely charged ions, definitely what will happen? They are attracted by each other, and that is nothing but ionic bond. So what is ionic bond? The electrostatic force of attraction holding the oppositely charged ions, that is called as ionic bond or the electrovalent bond. The strong electrostatic force of attraction between oppositely charged ions which are formed because of transfer of electrons, that is called as ionic bond or electrovalent bond. Let us understand better with the famous example of sodium chloride. What is the electronic configuration of sodium? What is atomic number of sodium? That is 11. Isn't it? What is electronic configuration? It is nothing but 2, 8, 1. Now, we know that sodium is a metal, and metal means always take part in bonding by losing electrons. So how many electrons it should lose in order to get 8 electrons in the outermost orbit? It is nothing but 1. So the sodium loses 1 electron, and once the sodium loses 1 electron, that is converted into sodium ion, isn't it? Now in sodium ion, what will be the electronic configuration? It is nothing but 2, 8. So it is getting that octet configuration. Now what is electronic configuration of chlorine? Atomic number is 17. So what is electronic configuration? It is 2, 8, 7. So how many electrons are there in outermost orbit of chlorine? 7. And we know that chlorine is a non-metal. It always takes part in bonding by accepting electrons. So this 1 electron is taken by this chlorine, and that is converted into Cl- ion. So after formation of Cl- ion, what will be its electronic configuration? It is nothing but 2, 8, 8. So both the sodium and chlorine, they are involved in chemical bond formation in order to get octet configuration in their valence shell. And in that process, anyhow, the potential energy is decreasing, or lowering of potential energy takes place. That is the reason why the newly formed molecule NaCl is stable than the individual atoms sodium and chlorine. So this oppositely charged sodium ions and chloride ions, they are held together by strong attraction forces, and that attraction force is called as the ionic bond. Let us discuss the formation of magnesium oxide. There is another example of this ionic bond. What is the electronic configuration of magnesium? Yes, atomic number is 12. How you write the electronic configuration? 2, 8, 2. So magnesium being a metal, it always takes part in bonding by losing electrons. So in order to get the octet configuration, it loses 2 electrons. So magnesium lost 2 electrons, and that is converted into magnesium ion. So what will be the electronic configuration of magnesium ion? 2, 8. As it is losing 2 electrons, it is converted into dipositive ion. Then oxygen. What is the electronic configuration of oxygen? As atomic number is 8, it is 2, 6. So it requires 2 more electrons to get the octet configuration. So those 2 are accepted by the oxygen, and that is converted into O2- ion. So then this also becomes 2, 8. Now what is identical here? Both the magnesium ion and oxide ion, after their formation, both have the same electronic configuration. So we can say these two as isoelectronic in nature. So what is the meaning of isoelectronic? Those species which have same number of electrons, they are called as isoelectronic. So after the formation of the molecule, both the cation as well as anion are having the same number of electrons, both in the outermost orbit as well as the total number of electrons. So we call this species with same number of electrons as isoelectronic. That is magnesium oxide. Let's go for one more example. Calcium chloride. What is the atomic number of calcium? Yes, it is 20. How we write the electronic configuration? 2, 8, 8, 2. So how it will take part in bonding? By losing electrons. How many electrons? 2 electrons. So it is losing 2 electrons. So electron 1 and electron 2, and that is converted into calcium ion. So after calcium ion formation, what is its electronic configuration? 288. Then let us see the case of chlorine. Chlorine atomic number is 17. How we write the configuration? 2, 8, 7. So it requires one more electron. Now here, even though calcium is giving 2 electrons or losing 2 electrons, chlorine does not require 2 electrons. So out of the 2 electrons, one chlorine atom will accept only 1 electron. So the second electron is accepted by one more chlorine atom. So both these individual electrons are taken away by 2 separate chlorine atoms, and both of them are converted into Cl- ion separately with the same electronic configuration 2, 8 and 8. See again same here, both the cation and anion both are having the same electronic configuration. Again this is an example of isoelectronic ions. So then the oppositely charged calcium ions and the chloride ions, they are held together by the strong attraction forces, electrostatic force of attraction called as the ionic bond. Is it clear? Now, can you tell me what is the common in all these examples? One is sodium chloride, magnesium oxide, as well as in calcium chloride. So don't say that in all the case metal loses electron and the anion or the non-metal accept electron. All those are very, very common things beyond those levels. Now here, when I write separately, it has one sodium ion and one Cl- ion. Then here, one magnesium ion and one oxide ion. Then here, one calcium ion and two Cl- ions, chloride ions. Now after this, tell me what is the common thing which you observe in all these 3 points. Now, if you take these two, in both the cases, the total number of cations is equal to total number of anions, isn't it? But what is this case here? There is only one cation and 2 anions. So here the number of cations is not equal to number of anions. So we cannot say that in every ionic compound the number of positive ions are equal to number of negative ions. But we can say one thing. What is that? Yes, the total positive charge is always equal to total negative charge, because we know that molecules are electrically neutral, and that is possible only whenever the total positive charge is equal to total negative charge. So see, one positive charge and one negative charge, 2 positive charge and 2 negative charge, 2 positive charge and 2 negative charge. So remember, in any ionic compound which is formed either by losing 1 electron, 2 electrons or 3 electrons, whatever it is, or gaining some number of electrons, always the total positive charge is equal to total negative charge. Now let me explain one more new word here, that is called as electrovalency. So what is this electrovalency? Electrovalency is nothing but the number of electrons lost or gained by an atom during the formation of an ionic bond. That is called as electrovalency. Now when you take the case of calcium chloride, in calcium chloride how many electrons calcium lost? 2, isn't it? So the electrovalency of calcium is 2. And what is the case for chlorine? Each chlorine is accepting 1 electron. So that is the reason for chlorine electrovalency is 1. If we consider for magnesium oxide, magnesium is losing 2 electrons. So its electrovalency is 2. Oxygen is accepting 2 electrons. So its electrovalency is again 2. So that is the meaning of electrovalency.